My name is Piotr, and I'm super excited to be talking at this conference. And I'm going to be talking about anonymizing P2 information, so sensitive information, in financial and medical documents. So the simple goal is that if you've got a bank statement, you want to identify where the P2 information is, so personality, well, I can answer that. The personal identifiable information in the document, and then replace it with a synthetic analog. So you have a new document which you can keep for training. So due to GDPR, you can't keep the original documents beyond the original use case. However, you want to ideally keep documents for training purposes. So what the talk is going to be about is about identifying the P2 information, removing them so you can keep the documents for further training of more sophisticated machine learning models. There's a really good talk by Eric Schmidt, you can just look up online. He argues strongly that the next $100 billion companies will be based on data and not AI models. That if you have enough data, especially if it's specialist and you need a specific business case, you can always train new machine learning models. But the core value of these companies will be the data and not the machine learning models. So let's say you work in a bank that does mortgage applications or sells mortgages between them. If you ever apply for a mortgage, you've got to provide a lot of documents. So pension certificates, employment contracts, tax certificates, that kind of stuff. Let's say you're a bank that's based in Prague, but because we're in the EU, you have people moving from Spain, from Poland, you're going to get a lot of different documents coming in. And ideally, you want to automate their extraction process so you can do it purely for compliance. But if you want to train custom models for this, you need the underlying data to be able to train them, but you can't keep the data because of the P2 information. Say even that, okay, you use a third-party model for extraction. It's very hard to compete with the big tech companies. Usually the AI models are state-of-the-art. But let's say you want to use them, it's still extremely useful to have this corpus of documents with all the weird edge cases here and there, because you can benchmark new machine learning models for extraction and classification as you slot them into your pipelines. So then you know what approximately it's going to look when it hits production. So there are three key techniques for this. So first, you have to identify the P2 information, and that's done something called named entity recognition. Second, you want to mask it. And third, you want to use a diffusion model to basically in-paint and make the document look similar to the original. So I want you to take a look at this image and try to tell me what's wrong with it. I asked ChatGPT to draw a picture of Europe. And to its credit, it actually did a pretty good job. The boundaries look pretty nice. Warsaw, I think, Warsaw and was where I live, also looks correctly spelled, but I'm not sure if it's geographically correct. But anyway, there are mistakes in there, and some of them are deceptive. You can't just throw a document into ChatGPT and get it to anonymize stuff. It's too inconsistent, it'll hallucinate. It's not quite there yet. So the first step, named entity recognition. I identify the P2 information. So going from simple to advanced, the simplest methods require a pre-OCR layer, so you extract the text and then you work on that. So regex actually works pretty well on simple things. So IBANs, for example, phone numbers, those kind of things. But more complicated things like addresses and names, you need to use more complicated models like SPACY. There are a lot of techniques out there. Moving beyond the OCR layers, there are also obviously vision language models, and you can throw those directly in as well. The text-based models, where they tend to fail, is where you have documents which are slightly distorted or damaged. So let's say you've got a bank document, but the last letter is a bit smudged, but the last number in IBAN is smudged. The OCR layer might screw it up, and SPACY or regex might have difficulty classifying it. So that's where the power of the vision language models come in, but they're much more complicated, and they're a lot trickier to deal with. My strong advice is always start off with SPACY and use it as a base case. and use it to benchmark any more advanced models. It's okay to use multiple models at once and multiple techniques to identify P2 information. At worst, you just anonymize too much information. That's not the worst case. The worst case is you miss something. It should also be noted that simpler techniques tend to be faster than more advanced techniques. So that's great. You've identified the P2 information, and you just treat it like the CIA, and you black it out. The problem with doing this is you alter the underlying document, and the data becomes out of distribution. You have to be extremely careful when you train sort of like machine learning models. So if you want to take bank statements and then use them for fine-tuning classification models and extraction models, you have to be careful what you feed into them. There's a classic machine learning paper from about 15 years ago where they trained a simple, I think, convolutional neural network to do classification of cats, dogs, and fish. And it came out pretty nice, like the actual statistics behind it. But when they did exploratory AI and looked at what does the model look at, for the fish, it turns out it looks at the fingers in the picture. So the underlying model, basically, so the underlying data set for fishes had basically people holding them up, and it learned the fingers and not the fish. So that's why you really want to avoid just blacking it out, because you're worried that any further extraction models down the line might recognize that instead of what you need. It's also okay to just black them out and keep it as a separate copy, and maybe use it as a reference. So, okay, we don't want to black out the P2 information, so we want to use diffusion models to do in-painting. Diffusion models are machine learning models where you add speckle noise to them, usually Gaussian, and then train the model to iteratively denoise the image. The naive approach is to just download stable diffusion and give it a sort of bounding box, say, hey, please take this. Here's a picture of a bit of text. Please in-paint. And this is what you get. So this doesn't actually look too bad. The font's a bit similar. This font is all a bit weird. But if you look closely, this one's 32 Kenwood Avenue. It's changed this to S2, and this one to 52 Kenwood Avenue. So it's actually gone beyond what we wanted to actually alter. So it's not just the font. So the main reason is that stable diffusion is trained on natural images and is trained to in-paint on natural images. So natural images are soft, like cats, dogs, people, cars. They all usually have soft boundaries, essentially, whereas text is quite sharp. So it's not used to reproducing things like this. Secondly, I don't know if you've ever tried to do Photoshop at home, where you just paste a cutout onto an image. It looks a bit weird. So the models are trained to basically work around the edges and sort of change the surrounding areas, essentially, for the in-painting. And we want to specifically control it. So it does in-paint, but it doesn't think too much outside its bounding box. So there's a lot of papers out there. The one that we were able to reproduce was a paper called Diffute by Ant Group. So I'm going to go through what they did, how we reproduced it, and give you examples of results. So vanilla stable diffusion has three main components. It has the UNet here, which does the denosing process. It has a variational autoencoder, which basically takes an underlying image, reduces it to a smaller matrix, so into a latent space, and then eventually reconstructs it. It's basically a computational trick that this UNet, the diffusion process, is very computationally expensive. So if we can take the original image here, make it smaller, do the diffusion process, and then reconstruct it, that actually saves a bit of computational time. Then they use OpenClip for conditioning, so you can add in text or representation of other images for the in-painting. What Diffute does is replaces OpenClip with TR-OCR, so it's an open source OCR engine, and hooks the embeddings in directly. Then they retrain the variational autoencoder, and then they retrain the UNet. So with the retraining process, it's two steps. Variational autoencoder first, and then the UNet. The variation autoencoder has to be retrained because it's trained naturally on natural images. It can handle some text because in the underlying data set, there were signposts, menus, that kind of stuff, but we wanted mostly to handle text really well. So you retrain this first. Then you fix the variation autoencoder. You take your document that you take the example document, you create a masked image and a noisy image. The mask is about a bit of text that you want to sort of like anonymize and reconstruct. And so you take the original text from here, you pass it into the OCR engine, and you train the UNet to reconstruct the original image. And you do that iteratively. What I thought was really cool about this paper, and I'm really, really clever, is that you don't just have to train on the P2 information, you train on every bit of text. So you just identify one bit of text, next bit of text, next bit of text, and each time you do the training process. So on a limited data set, you can actually do a lot of training to condition your model to behave exactly you want. And I thought that was very, very clever. Inference is just like training. So you take the original image, you create a masked image, and a noisy original image. But instead of using the original text, you're just feeding a new text and then get it to inpaint. So this is an example from a simple document. It hasn't done too bad. So for these two bits that I anonymized, this actually looks pretty consistent in terms of font. This font is a little bit off, and the alignment's a little bit off, but it's reasonable. The document does look consistent with the original. And admittedly, I could probably do this better in Photoshop, but this technique is automatic. But where the real power of this technique is when you're working with very complicated documents. So this document has a complicated background, and it's done an alarmingly good job at basically replacing the name and the P2 information in that. So this works better than I could Photoshop, essentially. So limitations of the edits. So for anonymization, you can't anonymize high net worth individuals. If you're extremely wealthy and you live in an area with a low population density, you can just de-anonymize, you can de-identify the person essentially based off that. Secondly, make sure you're consistent with the editing. So the name that you put in as a synthetic replacement should be approximately the same size so they match in the text. Try to keep the titles or approximate genders in the document as well consistent. So improvements to this process. There's another paper I'm trying to reproduce to hook into this. So traditionally, like I said, you retrain the variation autoencoder and the UNet separately. This paper claims you can do both at the same time, and that basically it improves the training process significantly. So it saves on my GPU training costs. I plan to sort of publish the code I've written and the models publicly once I've done this. It also claims to be a drop-in replacement for the training process for diffusion models. Okay, so in summary, I wanted to get across just how important data is for training machine learning models. Garbage in, garbage out. If you're able to acquire large quantities of high-quality data in a very niche domain, so it might be finance, medicine, doctor's notes, chemical strategies, that kind of stuff, that data is highly valuable, especially to you as a company. If you're working with financial medical documents, you can't keep them for training purposes because of GDPR. However, you can use diffusion models to anonymize the P2 information in them. You can't just throw them into Stable Diffusion 2. There are tricks around the training process. I reproduced the diffuse paper, and I've shown you the results. For context, in terms of the training process, the paper itself trained on about 5 million documents. I trained on about 1 million documents. I trained on 4 490 GPUs for 3 days for the variation autoencoder, and another 3 days for the UNet. So that's what the results I got. Finally, I want to thank the organizers of EuroPython. This is an amazing conference. I was here 2 years ago as a volunteer. I felt extremely welcome. I'm now as a speaker for the first time. It's a huge amount of effort to organize a conference. Thank you very much to the organizers, the volunteers. You're all amazing people. And you're all awesome. Thank you very much.
That deserves a huge wave of applause. Thank you very much. And now the time for questions.
A very naive question. Maybe I missed. You already answered. Maybe. So I couldn't get why you had to work on the images. Couldn't you just extract the texts and represent them in some vector and then just operate on the text? Because in the end, don't they end up in some database, or the end goal is to extract text from there, no? Or?
So the idea is that you want to be able to train your text and classification models, essentially. So if you work with a lot of documents, say here, right? Extraction, so let's say you plug into an extraction model now. How good is the extraction model, especially reading tables or charts or graphs? If that makes sense, like that, you want to be able to keep the underlying documents because the extraction models at the moment have issues with them and are likely to improve. So you want to be able to train new extraction methods as they come out. So this is before the extraction part, essentially.
I see, but if the extraction models improve to become quite good, then...
No, that's fantastic. If they become perfect or close to perfect, that's still great, but you still... So let's say, for example, Google and Azure's extraction models become 99.999% effective. That's fantastic. You still want to have the high quality sort of data set so you can benchmark them. Because what they will do is they'll train across whatever internal data they have, but that may not match yours exactly. So if you're a bank that's basically operating, so you might get random documents from different EU countries or very niche, or let's say you're working with in medicine and there's handwritten notes, for example, stuff like that. You want to be able to keep them all in so you can still sort of like benchmark the extraction methods.
I see, thanks.
Any more questions? All right. Oh, there is a microphone.
Yeah, thanks a lot for the great speech. I'm particularly interested in the area of masking the sensitive information just from the raw text, not necessarily from the image. And I wanted to ask, you mentioned the named entity recognition models. Do you know any good models, the pre-trained ones that could be used for financial data, or did you train your own models, or what would be your recommendation here?
I didn't quite understand the question. Could you say it a bit slower? So you were asking about models, but I didn't quite understand what you were asking about the extraction models.
No, I asked about the named entity recognition models for finding the PII information, like the P2 information in the raw text.
So we used a combination of things. Spatie, of course, is a base case. For the visual language models, we used a bunch of different ones. They keep changing all the time. You can fine-tune them, but they keep changing. They keep changing all the time. So I can't give you a solid recommendation because it'll be out of date in 2 weeks' time. But that's also where the usefulness of these documents come in, right? You can literally benchmark on them if you have the anonymized documents.
All right, any more questions?
I'm a bit interested in you mentioned handwritten text. How does it work with that then? Is it able to sort of maintain the same characteristics of writing, the handwriting style, or is it just looks handwritten?
It just looks handwritten.
Okay, yeah, makes sense.
I mean, most of what I trained on this was an open data set of what do you call it, of documents essentially, and so it wasn't much handwritten data on there. Technically, if I put in the handwritten data, I could probably sort of get it to reconstruct closer, but I didn't go down that approach.
Yeah, makes sense, because you presumably don't really sort of need it to be perfect. It's just got to look still handwritten. And, yeah.
Mm-hmm.
Yeah, thanks very much again. Just wondering, have you any comment on the possible misuse of this stuff for generating these really convincing, high quality, for example, identity documents?
Yep, you can pretty much misuse it, but This is based on open paper and open models as well, open code as well. So I'm reproducing something that's already out there.
I get you.
But if you're basically using this to forge documents, well, that's on the bank's fault that they haven't done KYC properly, accepting scans and not actually checking physical documents or using EIDs.
Can you clarify that last point, that what the bank's not doing properly?
For example, using electronic ID. So I'm based in Poland, for example. We have our own electronic identity system,
Yeah.
and that's what I use for identification.
So basically, you're saying that the documents for identification is obsolete. That's your point.
Pretty much.
Okay, thank you.
It worked fine 20 years ago.
Thanks for your talk. I would like to know your take about, for example, across all those documents, let's say it's all related to the same person, about anonymizing to the same entity so that you can afterwards correlate those documents when you're training the model. What's your take on that, and would you recommend doing that or not? Because potentially you could revert back to the original information.
Correct. So I wouldn't correlate between documents. So within the document, it makes sense because you might want to apply reasoning models to it and benchmark based on that. So if you have one consistent name or two or three consistent names, say it's I don't know, some kind of legal document. So you have two people's names on there and on there essentially. You want to replace them with two different people's names, but keep it consistent across that document, but not across other documents. You don't want to correlate.
Hi, thank you for the talk. So I can see that the diffusion model are quite useful for text documents, but I'm wondering if there's any models that's more useful for let's say I'm trying to anonymize license plate in a video, and there aren't many data that I can provide. Let's say I only have a 5-minute video license plate, and there are cars moving around. What do you think? If there are any other suitable models for that, or would you still say diffusion models are the way to go?
So you're trying to anonymize license plates, right? Yep. And I think the issue is just for that is just data, as you were suggesting, right? So I suspect diffusion would actually work quite well for that. But what you would need to do is just collect enough data. At that point, I don't know what the laws are in the Czech Republic, but you might be able to set up a camera and just collect it. Or if not, move to a district somewhere globally which you can do that.
Okay, thank you.
Okay, maybe for clarification, so the name that ends up in the document in the end, that the stable diffusion comes up with that
Nope.
name, or is that something you put in?
We generate it. We basically pick something at random. We just have to make sure that it's approximately consistent. If it looks like a gendered name, that's approximately consistent with that gender. But even that's not too important. The most important thing is the actual size of the name.
Okay, that answers my question actually. Thank you.
All right, any more questions coming? One more?
I was just wondering, as I understand it, you generate this synthetic data to use in further training of whatever. Mm-hmm. Is it possible to benchmark the synthetic data to ensure that it's not garbage, as you said, or that it would be as good as training on real data, if you understand my question? That what is generated, the synthetic data, is the same as would be, I don't know.
You could. I mean, one classic way is basically if you take you take the document, you anonymize it, and then put them both through an extraction model, essentially, to see how the extraction model sort of extracts from it. So it depends what you want to train downstream. Are you training a classifier? Are you training sort of an extraction model? Both will do, essentially, but you could technically compare them both.
Yeah. Okay,
so at one point, essentially, during the initial sort of anonymization process, you have access to both, essentially, so you can actually run that test at the same time.
Yeah, right. So you would sort of see the performance of the classifiers on the real data and then on the synthetic data. And so, yeah, okay, I see.
We have time for some more questions. All right, then I will allow myself to ask also a question. Whether the use cases, interesting use cases, when the attempts to preserve the usefulness of documents was compromised by the attempts to preserve the legacy, so to say, the privacy, I'm sorry.
So you're saying that that anonymizing them essentially like isn't good enough, or like it damages that the actual
the usefulness. It compromised the usefulness, and vice versa. When the attempts to preserve anonymity was compromised by usefulness, and the attempts to preserve usefulness was compromised by preserving anonymity.
There's definitely a trade-off between the two. So traditionally, you wouldn't keep the documents, and that's hard to keep it anonymous, to keep it to basically keep for privacy. And like of course you can just black out things. So that what the technique I've described essentially is just an improvement on that. That keeps it more consistent with the original. You do have to be careful. One more thing with the anonymization is that let's say you have a big legal document, for example. There might, even if there's no P2 information in it, there might be enough context in that text if you copy and paste into Google to reverse the anonymization. So it's not quite so straightforward. But you are sort of like removing some of the confidential information. Another use case could be, of course, inside big organizations where there's very strict data controls. And often, even if another organization, let's say data scientists, are supposed to have access, they will never be given access. They might be more likely to be given access to data if it's already been done through an anonymization pass.
Thank you so much. So, no other questions? Then thank you very much for insightful talk.